There's a motion hidden inside stillness. Even when the night sky appears calm, even when the stars seem fixed in their dark and ancient places, nothing is truly at rest. Earth turns beneath us. Earth travels around the sun. The sun carries its planets around the Milky Way. The Milky Way moves with a local group of galaxies. And beyond that, beyond the soft silver band of our galaxy, beyond the nearest clusters and the nearest filaments of light, there is a deeper motion still, a slow, immense drifting of galaxies through the cosmic dark. A motion that cannot be felt by the body, a motion that cannot be heard. A motion written only in the faint signatures of light, distance, redshift, and gravity. For decades, astronomers noticed that our region of the universe was not moving quite as expected. Galaxies were expanding away from one another with the general expansion of space, but layered over that expansion was another movement, a peculiar motion, a streaming, as though countless galaxies were being gently drawn toward some hidden region beyond the Milky Way. The local group, the family of galaxies that includes the Milky Way and Andromeda, moves at about 600 kilometers per second relative to the cosmic microwave background, and that motion points roughly toward the sky near Centaurus, in the broad direction associated with the Great Attractor. 600 kilometers every second, more than 2 million kilometers every hour. And yet there is no sensation of speed, no wind, no vibration, no sound. The whole world moves with us. The mountains, the oceans, the clouds, the moon, the sun, the planets, the entire Milky Way, all carried together through the deeper currents of the cosmos. If we could step outside our galaxy and look back from the darkness between galaxies, perhaps we would not see the motion at first. The Milky Way would seem like a pale barred spiral, a whirlpool of hundreds of billions of stars turning slowly in space. Around it would be smaller companions, the Magellanic Clouds, dwarf galaxies, streams of stars, the great Andromeda galaxy approaching over time, the local group bound together by gravity. But if we waited long enough and if our vision were broad enough, we would notice that this whole family is not simply drifting aimlessly. It is moving, not toward a single star, not toward a single planet, not toward a black hole, but toward something larger, stranger, and far more difficult to see. A region of hidden mass, a gravitational valley, a place in the cosmic web where galaxies flow as rivers flow down a dark landscape. Astronomers gave it a name that sounds almost mythological: the Great Attractor. The name is dramatic, but the reality is subtler than the name suggests. The Great Attractor is not one object waiting in the dark. It is not a giant black hole pulling the Milky Way into doom. It is not a cosmic monster with an edge, a surface, or a mouth. It is a region of space where matter is more concentrated than average, a vast gravitational feature connected with galaxy clusters, superclusters, and the flow of galaxies across hundreds of millions of light years. NASA describes the region as associated with the Norma Cluster, Abell 3627, the closest massive galaxy cluster to the Milky Way, about 220 million light-years away, whose enormous mass and gravitational attraction make that region known as the Great Attractor. 220 million light-years. That distance alone is enough to dissolve ordinary scale. Light, traveling fast enough to circle Earth more than 7 times in a second, takes about 220 million years to cross the distance between us and the Norma Cluster. The light that reaches us from that region tonight began its journey long before humans existed, long before the first flowers had bloomed on Earth, long before the continents had their present shapes. And yet, by cosmic standards, this is still our neighborhood. Not close in the human sense, not close in the sense of travel, but close in the architecture of the universe. The Great Attractor lies in the nearby universe, in the region of galaxies whose motions can still be studied as part of our local cosmic flow. It lies near the border of the constellations, Norma and Triangulum Australe, hidden behind the thick light and dust of our own galaxy. NASA notes that optical observation of the Great Attractor is difficult because the plane of the Milky Way outshines and obscures many objects behind it, although infrared and radio observations can help astronomers see through some of that darkness. This is part of the mystery. The Great Attractor is not hidden because it is small. It is hidden because we are inside a galaxy. We look outward from within the Milky Way, from a position embedded in a disk of stars, gas, and dust. When we look above or below the disk, the universe opens into deep fields of galaxies. But when we look through the crowded plane of the Milky Way, our view is blocked. Stars fill the foreground. Dust dims the background. Gas clouds scatter and absorb light. Behind the bright river of our own galaxy, countless galaxies disappear from ordinary view. Astronomers call this obscured region the Zone of Avoidance. It is a beautiful and eerie phrase. The Zone of Avoidance. A place on the sky where galaxies are not absent, but hidden. A place where the universe does not reveal itself easily. A place where maps once had a blankness, not because nothing was there, but because our own galaxy stood in the way. And behind that veil, in the direction of Norma, lies the core of one of the most mysterious gravitational puzzles in modern astronomy. The story begins not with a picture, but with motion. Galaxies carry light across space, and that light arrives stretched or compressed by their movement and by the expansion of the universe. Most distant galaxies are redshifted because space itself is expanding. The farther away they are, the faster they tend to recede from us in the broad pattern called the Hubble flow. But galaxies do not only follow the expansion of space, they also feel gravity. They fall toward clusters, they drift along filaments. They are tugged by neighboring structures. They move through the universe with peculiar velocities, extra motions layered over the general expansion. A galaxy can be carried away by cosmic expansion, and still, at the same time, move slightly toward a nearby concentration of mass. This is one of the quiet difficulties of cosmology. To understand the large-scale universe, one must separate motion from motion. There is the smooth expansion, and there is the local flow. There is the stretching of space, and there is gravity's old desire to gather matter together. The Great Attractor was not first found as a bright object in a telescope. It was found as a disturbance in the flow. Astronomers measured galaxy distances and compared those distances with redshifts. If the universe were expanding perfectly smoothly, a galaxy's distance and recession speed would follow a simple pattern. But the pattern was not perfectly smooth. Galaxies over a vast region were moving as if drawn toward a hidden mass concentration. In the 1980s, a group of astronomers, sometimes called the Seven Samurai, helped reveal this large-scale streaming motion by measuring distances to hundreds of elliptical galaxies and comparing them with their redshifts. Their work pointed toward a major concentration of mass that became known as the Great Attractor. Later studies refined the picture, but the essential mystery had already appeared. Something massive, partly hidden by the Milky Way, was influencing the motion of galaxies. It is tempting to imagine a single thing there, a cosmic object, a dark center, a black hole larger than imagination. But that is not what the evidence suggests. A black hole powerful enough to pull entire galaxy clusters from hundreds of millions of light years away would have other signatures, and the Great Attractor is not understood that way. It is a region, a concentration, a landscape of mass. Galaxy clusters, filaments, dark matter, hot gas, and the broader web of structure all contribute. It is less like a monster in space and more like a valley so large that galaxies move along its slopes. The word valley is useful but not because space has hills and valleys in the ordinary sense. Gravity creates a kind of landscape in the motion of matter. Where mass is concentrated, galaxies tend to flow inward. Where regions are underdense, galaxies tend to move away, relatively speaking. The cosmic web becomes a terrain of attraction and evacuation, of dense knots and empty voids. The University of Hawaii's description of Laniakea gives this image clearly. Within the Laniakea supercluster, galaxy motions are directed inward like water streams following descending paths toward a valley, and the Great Attractor region is described as a large, flat-bottom gravitational valley extending across that supercluster. A flat-bottom gravitational valley. It is a phrase that sounds calm, almost earthly, but its scale is almost beyond thought. Imagine streams at night, not water streams, streams of galaxies, Milky Ways and Andromedas, spirals and ellipticals, clusters and groups, all moving through an invisible landscape shaped by gravity. Some drift along filaments, some gather into knots. Some are carried by the expansion of the universe but still curve slightly toward denser regions. Their motion is slow only by cosmic standards. By human standards, it is enormous. The Great Attractor is one of the places where these streams appear to descend. But to understand it, we must widen the view. The Milky Way is not alone. It belongs to the local group, a gathering of more than a few dozen galaxies dominated by the Milky Way and Andromeda. The local group is part of the larger Virgo region, once described as part of the local supercluster. But modern mapping of galaxy motions has given us a still larger identity: Laniakea. The name means something like immense heaven or open skies, drawn from Hawaiian language and chosen in honor of Polynesian navigators who used the heavens to cross the Pacific. The Laniakea supercluster was defined by mapping the motions of galaxies and identifying a vast basin of attraction that includes the Milky Way. It is about 500 million light-years across and contains roughly 100,000 galaxies with a total mass around 100 quadrillion suns. 100,000 galaxies. Not stars, galaxies. Each one a city of stars, dust, gas, dark matter, and time. And we are not near the center. The Milky Way lies on the outskirts of this immense structure, one small spiral among thousands upon thousands, moving along with the flow. Laniakea is not a solid object. It is not a bound island in the way a galaxy is bound. It is a basin of motion, a region in which galaxies share a common tendency in their peculiar velocities. In one direction, streams converge toward the Great Attractor region. In other directions, the flows diverge toward other basins. Boundaries are not walls. They are gravitational watersheds. On Earth, a watershed determines where rain will go. A drop falling on one side of a mountain ridge may eventually flow toward one river. A drop falling on the other side may flow toward another. The boundary may be invisible at the scale of a single drop, but over distance it matters. In the cosmic web, galaxies also follow slopes. Not slopes of rock, but slopes of gravity. The Laniakea map is a map of these slopes. And the Great Attractor is the low region, the valley floor, toward which local flows descend. But the valley is partly hidden. The Milky Way's disk crosses the view. The same galaxy that gives us our home also blocks our sight. The same stars that make the night beautiful obscure the galaxies behind them. There is something almost poetic in that. We are pulled towards something we cannot clearly see because the place we live in stands in the way. For a long time, the zone of avoidance was a blindfold. Optical telescopes could see easily in many directions, but not through the densest regions of the galactic plane. Dust absorbs and reddens visible light. Star fields become so crowded that background galaxies are hard to separate from the foreground. The universe beyond the Milky Way becomes a whisper behind a wall. But astronomers have learned to listen in other ways. Infrared light can pass through dust better than visible light. Radio waves can reveal hydrogen gas in galaxies hidden by dust. X-rays can reveal hot gas inside massive galaxy clusters. By combining different wavelengths, astronomers can begin to reconstruct the hidden universe behind the Milky Way. The University of Hawaii's CIZA survey, for example, searched for X-ray signatures of galaxy clusters behind the Milky Way because X-rays can penetrate obscured regions and galaxy clusters are X-ray sources. This is how the invisible becomes partly visible, not by one image. Not by one telescope, but by layering clues. A radio detection here, an infrared galaxy there, an X-ray cluster hidden behind dust, a peculiar velocity measured from distance and redshift, a map built slowly across decades. The Great Attractor is not a mystery because astronomers know nothing about it. It is a mystery because what we know is incomplete, and because the known parts point toward an even larger structure. The Norma Cluster, Abell 3027, lies near the center of the Great Attractor region. It is massive, rich in galaxies, and close enough by cosmic standards to dominate the view once the Milky Way's obscuring layer is penetrated. NASA identifies the Norma Cluster as the closest massive galaxy cluster to us, at about 220 million light-years, and notes that its enormous concentrated mass makes the region known as the Great Attractor. Imagine the Norma Cluster in the dark, not one galaxy, many. Hundreds, perhaps thousands, gathered in a gravitational swarm. Large old galaxies, spirals stripped of gas, ellipticals glowing with ancient stars, hot gas filling the space between them, dark matter forming the unseen scaffolding, galaxies falling through the cluster, some colliding, some distorted, some losing gas as they pass through the hot intracluster medium. From far away, a cluster may look peaceful, a faint patch of galaxies suspended in space, but inside it, gravity is active. Galaxies move at high speeds. Gas is heated to millions of degrees. The cluster holds itself together with mass, much of it unseen. And when clusters gather into larger structures, their influence reaches farther still. The Great Attractor region is part of such a larger structure: Hydra-Centaurus, Norma, Centaurus, Pavo, Indus, and the web of galaxies that surrounds them. But even this is not the end of the story. Beyond the Great Attractor lies Shapley. The Shapley supercluster, also called the Shapley concentration, is a still more distant and massive concentration of galaxies in the direction of Centaurus, roughly hundreds of millions of light-years away. ESO has described it as the largest matter concentration in the local universe, within about 500 million light-years, and noted that it may account for a significant part of the gravitational pull once attributed to the Great Attractor. The Great Attractor, it turns out, may itself be moving in a larger flow. What first appeared to be the hidden destination may be only a nearby bend in a greater river. This is one of the most important truths about the Great Attractor. It is not the final answer. It is part of a hierarchy. The Milky Way flows with the local group. The local group belongs to larger flows. The Great Attractor draws part of the local motion. But the Great Attractor region and much of the nearby universe may also be moving toward Shapley. The University of Hawaii's X-ray mapping work concluded that only about 44% of the Milky Way's motion through space could be attributed to the gravitational pull of the nearby Great Attractor region, with the remaining motion tied to a larger scale flow toward the more massive Shapley supercluster. So, the mystery changes shape. At first the question was, what is pulling us? Then the question became, is the Great Attractor enough? Then, what lies beyond it? Then, how do all these structures fit into the cosmic web? And now, the answer is not a single hidden object, but a layered gravitational landscape. Attractor after attractor, valley after valley, filament after filament, voids and clusters, all contributing to motion. The Great Attractor is real, but it is not alone. It is not the whole darkness. It is one deepening in a larger cosmic terrain. To feel this, imagine the universe not as scattered islands, but as a web. Galaxies are not randomly sprinkled through space. On the largest scales, they form a cosmic web, long filaments of galaxies and dark matter, sheets of structure, dense knots where clusters gather, and vast voids where galaxies are sparse. The cosmic web is the universe's great architecture. It grew from tiny density differences in the early universe. In the young cosmos, matter was nearly uniform, but not perfectly. Some regions were slightly denser. Gravity amplified those differences over billions of years. Matter fell toward matter. Gas cooled. Galaxies formed. Clusters gathered. Filaments stretched between them. Voids emptied out. The Great Attractor is one of the knots and flows in that web. But unlike the stars of a constellation, it is not easily seen by eye. Constellations are patterns projected onto the sky. The Great Attractor is a pattern in motion and mass. To find it, astronomers must measure where galaxies are and how they move. They must disentangle the Hubble flow from peculiar velocities. They must peer through the Zone of Avoidance. They must map what is visible and infer what is hidden. The mystery is therefore not only the Great Attractor itself. The mystery is how we know it is there. A star can be seen. A galaxy can be photographed. A nebula can glow. But the Great Attractor is recognized partly by the behavior of things around it, like wind made visible by grass, like a planet discovered by the wobble of a star, like dark matter inferred from the motion of galaxies. The Great Attractor is a gravitational presence written in the movements of galaxies. It is not a bright object, it is a pattern of falling. But falling here must be understood carefully. We are not falling into the Great Attractor the way a stone falls to Earth. The universe is expanding. Dark energy affects the large-scale future. Superclusters are not necessarily bound forever. The distances are enormous, the motions are complex, and over cosmic time, many structures may drift beyond one another's reach. The Milky Way is not doomed to crash into the Great Attractor. In fact, before anything like that could happen, other events dominate our future. The Milky Way and Andromeda are moving toward each other and are expected to merge billions of years from now. The Sun will age. The local universe will evolve. Cosmic expansion will continue to stretch the largest scales. The Great Attractor is not a destination in the simple sense. It is a direction in the flow, a sign of mass, a feature of the cosmic river. Its mystery is not that it will swallow us. Its mystery is that we are moving right now, along with countless galaxies, through a landscape we cannot fully see. The hiddenness matters. There is a difference between a distant object and a veiled one. A distant galaxy at the edge of a deep field is faint because it is far away. With enough exposure, enough sensitivity, enough time, its light can be gathered. But an object behind the Milky Way is hidden behind foreground dust and stars. It is not merely faint, it is obscured. Its photons must pass through the crowded interior of our own galaxy before reaching us. Some wavelengths are blocked, others are confused. The background is contaminated by the foreground. We live inside the fog. To map the Great Attractor, astronomers must map through home. They must understand the dust of the Milky Way, the distribution of stars, the emission from gas, the contamination of our galactic plane. They must look in infrared and radio, in X-rays and redshifts. They must build catalogs of galaxies that were once invisible. And even now, the map is not complete. The Great Attractor is an object of science, but it also remains an object of imagination because it lives at the edge of knowledge, where the known structures fade into hidden ones. It is perhaps the perfect cosmic mystery, not supernatural, not imaginary, not myth, but real and incomplete. a mystery made not from fantasy but from data. The earliest hints came from the fact that galaxies did not behave as a perfectly smooth expansion would suggest. Redshift surveys revealed that galaxies had peculiar motions. Distance indicators allowed astronomers to estimate how far away galaxies truly were, not just how fast they seemed to recede. And when the difference between distance and redshift became clear, so did the flow. In the language of the universe, motion is confession. A galaxy may appear to recede because space expands, but if it recedes a little slower or faster than expected, something has influenced it. A hidden mass concentration can draw galaxies toward it, reducing or increasing their observed recession depending on where they lie. Across many galaxies, these small deviations form a pattern. A single galaxy can mislead. 1,000 galaxies can reveal a current. The Great Attractor was inferred from such currents. It was not simply seen, it was felt through motion. This is why the name is so powerful, attractor. It sounds active. It suggests something reaching across space. But gravity does not reach like a hand. Gravity curves motion through space-time. On large scales, in the cosmic web, mass concentrations shape the paths of galaxies, while the expansion of the universe continues. Gravity and expansion together create a flow. The Great Attractor is a region where the flow descends. And because it lies partly hidden, it becomes a shadow in the map, a shadow with gravity. The cosmic microwave background adds another layer to the story. The CMB is the ancient afterglow of the early universe. Radiation released when the cosmos became transparent, now cooled to microwave wavelengths. It fills the sky almost uniformly. But it has a dipole pattern. One side of the sky appears slightly warmer and the opposite side slightly cooler, a pattern largely interpreted as the result of our motion relative to this cosmic background. Swinburne Astronomy notes that after accounting for this dipole, the remaining CMB temperature variations are astonishingly uniform, at about 1 part in 10,000. The dipole is like a cosmic wind indicator. If you move through a field of radiation, light in the direction you move is slightly blue-shifted, appearing warmer, while light behind is red-shifted, appearing cooler. The effect is tiny, but measurable. From it, astronomers infer motion relative to the CMB frame. And that motion points us toward the problem. Why are we moving this way? What mass distribution caused this velocity? What structures have pulled and shaped our motion over billions of years? The Great Attractor was one of the answers. Then Shapley became part of the answer. Then the larger web became part of the answer. Cosmic motion is not usually caused by one thing. It is the sum of many tugs. Nearby structures pull strongly because they are close. Distant structures can matter if they are massive enough. Voids matter too, because a lack of mass in one direction can contribute to relative motion away from emptiness and toward density. The universe is not only pulled by matter, it is also shaped by absence. Voids are not truly empty, but they are underdense. Compared with rich clusters and filaments, they contain fewer galaxies. Matter tends to flow away from voids and toward denser structures. In some modern descriptions, cosmic flows can be understood as a combination of attraction toward overdensities and apparent repulsion from underdensities. This makes the Great Attractor even less like a single object. It is part of a balance. The Milky Way's path is shaped not only by what lies ahead, but by what is missing elsewhere. The cosmos is a landscape of presence and absence. Clusters are mountains of mass. Voids are hollows of scarcity. Filaments are roads. Galaxies are travelers. And the Great Attractor is one of the dark valleys in this terrain. To imagine it visually, picture a vast black ocean. Not water, but space. Across it, threads of light stretch for hundreds of millions of light years. At their intersections, clusters glow faintly, like cities seen from far above at night. Between the threads are immense dark regions, voids where galaxies are rare. Our Milky Way is one light among many, not isolated, not central, but caught in the flow of the web. Now place a veil across part of the view. That veil is the Milky Way's own disk. Behind it, in the direction of Norma, the map becomes uncertain. Yet galaxies around the veil move as though a gravitational low point lies there. X-rays reveal clusters. Infrared surveys reveal hidden galaxies. Radio observations pass through dust. Piece by piece, the veil thins. A cluster appears, then another, then a wall, then a larger flow. The Great Attractor becomes less like a hidden beast and more like a hidden geography. The mysterious thing is not that one object has been concealed. It is that an entire landscape lies behind the bright foreground of our galaxy. The Norma Cluster is a key feature in that landscape. It lies in a region rich with galaxies near the plane of the Milky Way, in the direction where optical observations struggle. It is sometimes considered the core of the Great Attractor region. But even this cluster is only one part. Around it are other clusters, filaments, and walls of galaxies. The Great Attractor is a complex, not a point, a complex of mass, a convergence of flows, a place where the cosmic web thickens. The term Great Attractor emerged before the full structure was mapped. It captured the sense of a hidden source of motion. But as observations improved, the picture became more nuanced. The mass of the nearby Great Attractor region was revised downward in some studies. The more distant Shapley supercluster appeared increasingly important. X-ray surveys found that the Great Attractor was less massive than originally thought, and that the Shapley supercluster was a major contributor to the large-scale motion. This does not make the Great Attractor unreal. It makes it more interesting. A mystery that becomes more complex is not solved in the shallow sense. It becomes deeper. The question changes from what is the object to how is the whole nearby universe moving? And that is a better question, because the universe rarely arranges itself for simple answers. The Great Attractor is not a final destination, but a chapter in the story of cosmic flows. It sits within Laniakea, and Laniakea itself may be part of larger structures and motions. Beyond the Great Attractor lies Shapley, and beyond Shapley, still more structures. The cosmic web does not end where our current maps become difficult. The more we see, the more we find that our neighborhood is not isolated. The Milky Way is part of a group. The group is part of a flow. The flow is part of a supercluster basin. The basin lies within a still larger web. Every scale opens into another. This is one reason the Great Attractor has such a strange emotional power. It reveals that our galaxy has a direction we did not choose, a cosmic current, a hidden pull. We are not stationary observers, watching the universe expand around us. We are participants, moving through the web. The earth beneath our feet seems stable because all our local surroundings share our motion. But in a larger frame, the whole Milky Way is moving at hundreds of kilometers per second through the cosmic background. The local group streams through space. Clusters flow. Superclusters define basins. Space expands. Stillness was always local. Motion was always deeper. There is also humility in the Great Attractor. It reminds us that our maps are shaped by our position. If we lived far above the plane of the Milky Way, perhaps the Great Attractor region would be easier to see. If our solar system were located in the outer halo of the galaxy, away from dust and crowded star fields, the zone of avoidance might not dominate our view in the same way. But we live inside a disk. Our sky is not a neutral window. It is a window with curtains. The Milky Way is beautiful and obstructive. It gives us stars and hides galaxies. It is home and foreground. This duality is central to astronomy. We study the universe from a position inside it. We cannot step outside the Milky Way to photograph it from afar. We cannot view the cosmic web from some absolute external place. We build maps from within the structure we map. The Great Attractor is a lesson in that limitation, a lesson in hidden background. A lesson in the fact that even the direction of our motion may be partly concealed by our own galaxy. And yet, science finds ways through. The history of the Great Attractor is the history of seeing indirectly, measuring galaxy motions, mapping redshifts, developing distance indicators, surveying the sky in infrared, searching for hidden clusters in X-rays, using radio waves to detect galaxies behind dust, combining thousands of observations into maps of velocity and density. The Great Attractor is not a single image. It is a reconstruction, a slow unveiling. To understand why it matters, one must understand peculiar velocity more deeply. In an expanding universe, distance and recession velocity are linked. The farther a galaxy is, the faster space carries it away from us. But if a galaxy is near a massive concentration, its motion is altered by gravity. The observed redshift includes both cosmic expansion and local motion. If we can estimate the true distance independently, we can compare the expected expansion speed with the observed redshift and infer the peculiar velocity. This is difficult. Distances to galaxies are hard. Astronomers use methods such as Cepheid variables, type Ia supernovae, surface brightness fluctuations, the Tully-Fisher relation for spiral galaxies, and other distance indicators. Each has uncertainties. Errors can create biases. Large samples are needed. The farther away we look, the more subtle the problem becomes. The Great Attractor emerged from these painstaking measurements. It is not a dramatic object sitting conveniently in a telescope field. It is the result of patient comparison, distance against redshift, motion against expectation, the cosmic flow against the smooth expansion. Like listening for a low note beneath a choir, astronomers heard a hidden motion beneath the Hubble flow. The note pointed toward Centaurus and Norma, toward the Zone of Avoidance, toward the Great Attractor. The name may suggest certainty, but the science has always carried uncertainty. Early estimates of the Great Attractor's mass were large. Later surveys revised them. The role of Shapley grew. The role of Laniakea reframed the Great Attractor as a gravitational valley. New surveys continue to refine the hidden structures near the galactic plane. This is not a weakness. It is how astronomy works. The universe is not handed to us labeled and complete. It is inferred, corrected, redrawn. A mystery becomes a model becomes a map is tested, the map changes, and in that changing map, the Great Attractor has slowly transformed from a mysterious unseen mass into part of a larger cosmic flow network. Yet the mystery remains because the scale is vast, the region is partly hidden, and the flow is still being understood. The Great Attractor is not supernatural, but it is sublime. It belongs to that category of things that become more wondrous when explained correctly. To say it is a black hole would be simpler and more dramatic, but wrong. To say it is a gravitational basin involving galaxy clusters, dark matter, peculiar velocities, the Zone of Avoidance, Laniakea, Shapley, and the cosmic web is less simple and far more beautiful. Because then the Great Attractor becomes a sign of the universe's structure. A reminder that galaxies do not drift alone. A reminder that the cosmos has currents. A reminder that unseen mass can shape visible motion. A reminder that our galaxy has a path through the dark. Let us move slowly outward from Earth. First, the planet. A blue world turning beneath thin clouds. At the equator, Earth spins at about 1,670 kilometers per hour. But that motion is local, a turning beneath the sky. Earth also orbits the Sun at about 30 kilometers per second. The Sun shines at the center of the solar system, carrying planets, moons, asteroids, comets, and dust. The Sun itself orbits the center of the Milky Way, moving through the galaxy with its own immense speed, completing one galactic orbit in roughly hundreds of millions of years. The Milky Way and Andromeda approach one another within the local group. The local group moves relative to the cosmic microwave background, and that motion is tied to the gravitational architecture around us. Layer by layer, rest disappears. The more widely we look, the more motion we find. And yet every layer feels still from within. You do not feel Earth's rotation because you rotate with it. You do not feel Earth's orbit because you orbit with it. You do not feel the solar system's galactic motion because everything around you shares it. You do not feel the local group's motion because galaxies are not air rushing past your face. Cosmic motion is silent. It leaves no breeze. Only light remembers it. Light from the cosmic microwave background, slightly warmer in one direction and cooler in the other. Light from galaxies shifted by expansion and peculiar motion. Light filtered through the Milky Way's dust, hiding the region we most want to see. The Great Attractor is not felt in muscle. It is felt in measurement. This gives it a strange intimacy. Every person on Earth is moving with the Milky Way toward the same hidden region. Every breath, every city, every forest, every ocean wave, every quiet evening is part of a galaxy in motion. The movement is not urgent on human timescales. Nothing in ordinary life is affected by it. It does not change the tides, the seasons, or the path of the moon. But it is real. You are part of the flow, not symbolically, physically. Gravity shapes the path of the galaxy that carries you. And because the path is shaped by structures hidden behind the Milky Way, part of your cosmic motion is tied to something you cannot see with ordinary eyes. This is the essence of the Great Attractor's mystery. Motion toward the unseen. A hidden region written into the speed of home. The Great Attractor also forces us to think about scale in a different way. A star is massive. A galaxy is more massive. A galaxy cluster is enormous. A supercluster is larger still, but not always bound like a galaxy or cluster. On the scale of superclusters, the expansion of the universe becomes important. Structures may be identified by density, by galaxy distribution, by velocity flows, or by gravitational basins. Different definitions can reveal different boundaries. Laniakea, for example, is defined not simply by where galaxies are dense, but by how galaxies move. It is a basin of attraction. A motion-defined homeland. The Milky Way lies inside it because its flow belongs to that basin. This makes Laniakea less like a continent on a map and more like a drainage basin. But cosmic drainage basins may not be permanent. Dark energy and cosmic expansion can carry large structures apart over time. Some superclusters are not gravitationally bound in the way galaxies are. They may be transient patterns in the evolving universe, meaningful now, but not eternal. The Great Attractor itself is therefore a present-tense feature of cosmic flow, a structure in the current epoch, a valley in the motions we observe now. Over immense timescales, the cosmic web changes. Expansion stretches space. Bound structures remain together, while unbound structures drift apart. The future universe will not preserve every present pattern. The Great Attractor is not timeless. It is part of cosmic history. It emerged as matter comped over billions of years, and it will evolve as the universe continues. This makes it more mysterious, not less. It is not a fixed, godlike object. It is a temporary form in the long evolution of structure, a great gravitational weather system in the nearby universe, weather made of galaxies. When we think of weather, we imagine clouds, winds, rain, currents. In the cosmic web, the equivalent is density, velocity, flow, and gravity. Galaxies stream along filaments like leaves in rivers, but the rivers are hundreds of millions of light years long, and the leaves are star systems beyond counting. The Great Attractor is one of the low-pressure systems of this cosmic weather, a region toward which matter flows. But because the atmosphere here is the universe itself, the weather lasts for billions of years. There is another reason the Great Attractor feels haunting. It sits in the direction of Centaurus, a region of sky already rich with astronomical significance. Centaurus contains Alpha Centauri, the nearest star system to the Sun, though Alpha Centauri is a foreground neighbor, not related to the Great Attractor's distance. Centaurus also hosts galaxies and clusters in the broader southern sky. The direction is layered, nearby stars, Milky Way dust, hidden galaxies, distant clusters, the Great Attractor region, and beyond it Shapley. Looking there is like looking through a stack of cosmic veils. First, the stars of our galaxy, then dust, then hidden galaxies, then clusters, then superclusters, then the larger web. The line of sight becomes a tunnel through many scales of reality. And because the most important structures are partly hidden, imagination naturally fills the dark. But scientific imagination is not fantasy. It is disciplined by evidence. The Great Attractor invites a special kind of awe, the awe of inference. We cannot simply see everything, but we can know something is there because the universe around it moves. This is one of the deepest patterns in science. Neptune was discovered because Uranus moved strangely. Dark matter was inferred because galaxies and clusters moved in ways visible matter could not explain alone. Exoplanets can be detected by the wobble of their stars or the dimming of starlight when they pass in front. Black holes can be found by the motion of stars around invisible centers, or by hot gas spiraling inward, or by gravitational waves. The Great Attractor belongs to this lineage of hidden things revealed by motion. The unseen writes itself into the seen. Gravity is often the handwriting. At the scale of galaxies and clusters, dark matter is essential. Galaxy clusters contain far more mass than visible stars alone can explain. Hot gas emits X-rays. Galaxies move within clusters, and gravitational lensing can reveal mass distributions. The Great Attractor region, like other large-scale structures, includes dark matter as part of its gravitational mass. This should be said carefully. The Great Attractor is not made of dark matter, in the sense of being a dark matter object alone. It is a region containing galaxies, clusters, gas, and dark matter. Dark matter helps provide the gravitational scaffolding of the cosmic web. The visible galaxies are like lights strung along a much larger invisible framework. In a way, the Great Attractor is hidden twice, hidden by the Milky Way's dust, and hidden by the fact that much of its mass is not luminous. Even where galaxies can be seen, their visible light is only part of the matter story. The true gravitational landscape includes dark matter halos around galaxies, dark matter in clusters, and the unseen mass of filaments. The universe is bright only on the surface. Beneath the glow, gravity belongs largely to the dark. This is why the Great Attractor's mystery merges with the mystery of the cosmic web itself. We can map galaxies. We can map hot gas. We can infer dark matter. We can reconstruct velocities. But the full mass distribution is not simply visible. It must be modeled. It must be inferred from many kinds of evidence. And behind the Milky Way, that task becomes harder still. The Zone of Avoidance is not a small inconvenience. It covers a significant band of the sky. For studies of nearby large-scale structure, missing galaxies behind the plane of the Milky Way can distort our understanding of the mass distribution. If a major supercluster lies hidden there, it can affect motions while remaining difficult to identify optically. The Great Attractor was born from this tension. Something seemed to be pulling. But the direction was obscured. So astronomers had to ask, what mass lies behind the veil? The answer was not immediate. Norma, Hydra-Centaurus, Shapley, Laniakea, Vela, and other hidden structures in ongoing mapping. Each survey added pieces. Each piece changed the shape of the puzzle. The Great Attractor became not a final object, but an evolving story of cosmic cartography. Cartography is the right word, not because space is flat like a paper map, but because the effort resembles exploration. Early maps had blank regions, uncertain coastlines, imagined lands, and partial sketches. Over time, explorers filled them in. Mistakes were corrected, coastlines sharpened. Mountains appeared, rivers were traced. In cosmic cartography, the blank regions are not oceans but obscured sky. The explorers are telescopes. The ships are wavelengths. Infrared sails through dust better than visible light. Radio passes where optical light fails. X-rays mark the hot atmospheres of clusters. Redshifts give distances and motions. Catalogs become maps. And on those maps, the Great Attractor is one of the once blank regions where the hidden universe began to take form. But even the name Great Attractor comes from a particular moment in science. It reflects the feeling of discovery when the flow seemed to demand a massive unseen source. Later work showed that the flow is distributed and hierarchical. If the object were named today, perhaps it might be called something less dramatic: the Norma Basin, the Laniakea Valley, the Hydra-Centaurus flow convergence. But names are fossils of discovery. They preserve the emotional state of the moment when something first became strange. The Great Attractor remains because it feels true to that moment. Something great, something attracting, something hidden. Even if the scientific meaning is more nuanced, the name carries the night sky mystery that first drew attention to it, and the mystery is not false. It is only larger than the name. The Great Attractor teaches that the universe is not fully visible from any one point. It teaches that motion can reveal what light conceals. It teaches that our galaxy is part of a larger flow. It teaches that what appears to be a destination may itself be moving towards something greater. It teaches that the local universe has structure, direction, and hidden mass. It teaches that cosmic maps are still incomplete. Consider the phrase local universe. It sounds almost cozy. Local, nearby, familiar. But in astronomy, the local universe can include distances of hundreds of millions of light years. The Norma Cluster at 220 million light years is local in this sense. Shapley, at roughly hundreds of millions of light years, is local compared with the observable universe, whose light reaches us from billions of years away. Locality expands with scale. For a human being, local means the room, the town, the valley. For the Earth, local means the solar system. For the Milky Way, local means the local group. For cosmology, local can mean a volume hundreds of millions of light years across. The Great Attractor is local only because the universe is so vast. That word alone reveals how cosmic scale bends language. Nearby can mean unreachable. A neighborhood can contain 100,000 galaxies. A valley can be 500 million light-years wide. A motion can be hundreds of kilometers per second and still feel like perfect rest. The Great Attractor lives in this altered language. To narrate it properly, one must let ordinary words become enormous. Flow, valley, neighborhood, hidden, motion. Each word expands until it can hold galaxies. Imagine now a map of Laniakea. Not a map of stars as points, but a map of streams. White lines tracing galaxy motions. Each line a path through the invisible terrain. They curve inward not randomly, but toward a common region. Around them, colored boundaries mark the basin. Beyond the boundary, other flows belong to other basins. The Milky Way appears not as the center, but as a small point on the outskirts. Home is peripheral. The valley lies elsewhere, and yet our motion belongs to it. This is humbling. For most of human history, Earth was imagined as central. Then Earth became one planet among others. The Sun became one star among many. The Milky Way became one galaxy among billions. And now even our local supercluster identity places us on the edge of a flow, not at the center of the valley. The Great Attractor is a reminder of displacement. We are not central to the solar system, not central to the galaxy, not central to the local group, not central to Laniakea. But we are not meaningless. We are participants in structure. A small world carried by a star, carried by a galaxy, carried by a group, carried by a flow. The universe is not arranged around us, but we are arranged within it. This can be more beautiful than centrality. To be central is to be fixed. To be within the flow is to belong. The Great Attractor makes belonging cosmic. Everything near us is part of a moving pattern. The Milky Way, Andromeda, nearby groups, clusters, and galaxies all participating in large-scale motion shaped by gravity. Not marching toward one final point, but streaming through a web whose contours we are still learning. If one could somehow accelerate time, millions of years passing like seconds, the galaxies would move. Not visibly at first, then subtly. Clusters would shift. The Milky Way and Andromeda would draw together. Other galaxies would drift according to expansion and gravity. The cosmic web would evolve. The Great Attractor's flow would not look like water rushing. It would be slow, majestic, almost geological. But in the deep time of the universe, even galaxies travel. The word attractor can also be understood mathematically. In dynamical systems, an attractor is a state or region toward which a system evolves. In cosmic flow maps, attraction is gravitational, but the image is similar. Paths converge. The Great Attractor is a convergence, a place where motion points. But in general relativity and cosmology, gravity is not simply Newton's pull across empty space. On large scales, matter, dark matter, and the expansion of space-time shape motion. Galaxies move within the evolving universe, following paths influenced by the density field. The Great Attractor is a feature of that density field. It is both a place and a pattern, both mass and motion, both known and obscured. The more one thinks about it, the less it resembles a conventional object. A planet has a surface. A star has a photosphere. A galaxy has stars and gas arranged in a recognizable structure. A black hole has an event horizon. A galaxy cluster has a population of galaxies bound together. But the Great Attractor is not one of these categories exactly. It is a region of influence, a gravitational complex, a convergence within Laniakea, a historical name for an overdensity and flow pattern partly hidden in the zone of avoidance. To describe it accurately, one must let it remain diffuse. That diffuseness is part of its mystery. Human imagination likes edges. Where does it begin? Where does it end? What does it look like? How big is it? What is at the center? But cosmic structures do not always have clean edges. Filaments fade into clusters. Clusters connect to walls. Walls border voids. Basins of attraction are defined by flows, not fences. The Great Attractor is not a sphere with a sharp boundary. It is a region where the gravity of many masses combines. A slope in a landscape whose edges are defined by motion. This is difficult to visualize, and that difficulty is honest. The universe is not obligated to fit the shapes our minds prefer. The Great Attractor's lack of a clear surface makes it more real, not less. Nature often works through fields, gradients, and distributions. A cloud has no exact edge. A forest thins into open land. A river delta branches. A gravitational basin fades into another. The Great Attractor is cosmic in this way. A distributed thing. A fog of galaxies and dark matter. A flow convergence. A hidden valley. Now consider the role of time. The Great Attractor, we infer, is not exactly as it is now. because light from the region has taken hundreds of millions of years to reach us. When we observe galaxies in the Norma Cluster, we see them as they were about 220 million years ago. Shapley, farther away, is seen from an even older epoch. In cosmology, distance is always time, so the Great Attractor is hidden not only by dust, but by time. We observe its past, we infer its influence. Its present state is inaccessible in the ordinary sense. By the time light from its present reaches future observers, Earth itself will have changed beyond recognition. This is true for all distant astronomy, but it adds to the atmosphere of the Great Attractor. We are moving in response to gravity shaped over cosmic history, while observing the light from ancient versions of the structures involved. The universe is not a live picture, it is a layered memory. The Great Attractor is a gravitational memory influencing motion. Its light is old. Its pull reflects mass that has evolved. Its full present is beyond us. And yet, through physics, we can reconstruct a meaningful story. The story is not exact in every detail, but it is grounded. The Norma Cluster is there. The Milky Way's plane obscures it. Galaxy flows point toward the region. Laniaka's basin converges there. Shapley contributes beyond it. The local group moves relative to the cosmic microwave background. The Great Attractor is not myth. It is a real chapter in the map of the nearby universe. But because it is real, it must be allowed to be complicated. There is a common temptation in cosmic storytelling to sharpen every mystery into a monster. The Great Attractor becomes a black hole. Dark matter becomes a shadow substance with intention. Expansion becomes an explosion. The universe becomes a chase. But the true story is quieter and deeper. The Great Attractor is not hunting us. It is not waiting. It is not conscious. It is mass arranged across space and gravity doing what gravity does. The Milky Way's motion is not panic. It is participation in cosmic structure. The mystery is not danger. The mystery is hidden order. And hidden order is often more powerful than fear. When we speak of the Great Attractor, we are speaking of the fact that the universe has shape beyond what we can see. We are speaking of the possibility that the largest motions near us are guided by structures partly behind a veil. We are speaking of the way local galaxies stream not randomly, but in response to the cosmic web. The darkness is not empty, it has direction. This is perhaps the central feeling. The darkness has direction. If you stand beneath a clear night sky, you may see the Milky Way as a pale band overhead. To the eye, it appears still. But that band is the disk that hides part of the universe behind it. Somewhere beyond its dust, beyond its crowded stars, lies the Norma Cluster. Around it, the Great Attractor region. Beyond it, Shapley. Around all of it, the great flow of Laniakea. The visible sky is only the first layer. The deeper sky is motion. The Great Attractor is one of the reasons the night is not merely beautiful, but dynamic. It is not just a ceiling of stars, it is a map of moving structures. And we, from inside one galaxy, are trying to understand where we are going. There is a human resonance in that question. Where are we going? In daily life, it is philosophical. In cosmology, it is literal. Our galaxy has a trajectory through the cosmic frame. Our local group has a peculiar velocity. Our supercluster basin has a flow. The Great Attractor is part of the answer to the motion of home. It gives direction to something so vast we rarely imagine it moving at all. The Milky Way seems too large to be carried. But it is carried. A galaxy of hundreds of billions of stars, carried by gravity through the web. And each star carries planets. And on one planet, minds measure the motion. There is another subtle truth. The Great Attractor was discovered because the universe is not perfectly uniform on smaller cosmic scales. On the very largest scales, the universe appears broadly homogeneous and isotropic, meaning it looks roughly the same in all directions and locations when averaged over huge distances. But on the scales of galaxies, clusters, and superclusters, matter is clumpy. Without clumpiness, there would be no galaxies, no stars, no planets, no observers. The Great Attractor is part of this clumpiness, a feature of the universe's departure from perfect smoothness. The same gravitational instability that built galaxies also built clusters and superclusters. The same primordial density ripples that eventually produced the cosmic web also produced the environments where galaxies could form. The Great Attractor is not an anomaly against the universe's laws, it is a consequence of them. It is unusual from our perspective because of its scale and hidden location, but it belongs to the natural growth of structure. This matters because it makes the mystery lawful. The Great Attractor does not challenge physics in the sense of requiring magic. It challenges observation and mapping. It asks us to account for mass behind the Milky Way and beyond it. It asks us to understand cosmic flows across huge distances. It asks us to refine the map. It is a mystery of geography, not a violation of nature. And cosmic geography is enough. One does not need supernatural darkness when natural darkness contains 100,000 galaxies. Think again of Laniakea, a supercluster not defined merely as a pile of galaxies, but as a basin of flow. Its galaxies move like rainwater descending toward a gravitational valley. The Great Attractor sits near the valley's bottom, yet the whole basin may not be gravitationally bound forever. In the far future, expansion may pull many of its parts apart. The structure is real, but temporary. This is the strange impermanence of cosmic structures. A galaxy can be bound, a cluster can be bound, but a supercluster may be a passing arrangement on the largest scales. A shape in the river, a wave that lasts billions of years and then disperses. Laniakea may be our cosmic address now, but not forever. The Great Attractor may define a present flow, but not an eternal destiny. The universe builds and unbuilds. Gravity gathers. Expansion separates. The Great Attractor lives between these tendencies. It is a place where gravity's gathering remains visible against the expansion. But the expansion of the universe is the deeper background. Even as galaxies stream toward dense regions, the fabric of cosmic distances continues to grow. This makes the motion subtle. We are not moving through a static universe toward a fixed point. We are moving within an expanding, evolving universe whose structures themselves are changing. The word toward is therefore incomplete. We move toward the Great Attractor region in the sense of peculiar velocity. But space expands, structures evolve, gravity acts over time. The destination is not a simple arrival, it is a vector in a changing cosmos. This is why the Great Attractor is better understood as motion within a flow than as a place we will reach. A river current can carry a leaf toward a bend, but if the river itself changes, if tributaries enter, if the landscape shifts, the notion of destination becomes fluid. The Milky Way's cosmic journey is like that. It is not a straight road. It is a flow through a web. There is also a profound difference between the Great Attractor and the objects more familiar from space documentaries. A black hole is dramatic because it has a boundary, the event horizon. A neutron star is dramatic because it compresses stellar mass into a city-sized sphere. A supernova is dramatic because it explodes. A nebula is dramatic because it glows. The Great Attractor is dramatic because it is not one thing. Its grandeur is distributed. Its influence is statistical. Its form is inferred. It is a mystery made of maps. That makes it harder to visualize, but also more haunting. The Great Attractor is what happens when the universe itself becomes the object, not a star inside the universe, not a galaxy inside the universe, but the arrangement of galaxies and the movement of cosmic neighborhoods. To study the Great Attractor is to study the large-scale structure of reality, the pattern of where matter has gone, the currents created by billions of years of gravity, the cosmic web near our home galaxy. It is astronomy at the scale where individual stars vanish into points, galaxies become particles, and clusters become knots. On this scale, the Milky Way is not a majestic spiral. It is a tracer, a moving dot, a small ship in the current. This is humbling, but also serene. The universe is not diminished by our smallness. It becomes more spacious. A mind capable of recognizing its place in a 500 million light-year flow has become part of the universe's self-awareness, however briefly. The Great Attractor may not care. Gravity has no intention. But understanding gravity's pattern is a remarkable act for a species on a small rocky planet. There is a quiet wonder in that. A creature made of atoms forged in stars can infer a hidden gravitational valley hundreds of millions of light years away. Not by traveling there, not by seeing it directly, but by measuring the motions of galaxies. The Great Attractor is a triumph of indirect knowledge. Now let us descend into the zone of avoidance, not physically, but in imagination. The Milky Way's disk stretches before us. Stars fill the view, countless points bright and faint. Between them lie dark lanes of dust. To the eye, the Milky Way looks like a river of light. To an extragalactic astronomer, it can be a wall. Behind this wall are galaxies. Some are entirely hidden in visible light. Some are dimmed and reddened. Some are confused with foreground stars. For decades, these hidden regions left gaps in maps of the nearby universe. It was not that astronomers avoided them out of disinterest. They avoided them because observation was difficult, hence the name. Zone of Avoidance. The name sounds like a warning, as if the sky itself says, "Do not look here." But modern astronomy has learned to look anyway. In infrared, dust becomes less opaque. In radio, neutral hydrogen in hidden spiral galaxies can be detected. In X-rays, massive clusters reveal themselves through hot gas. With each wavelength, the zone becomes less empty, and the Great Attractor becomes less imaginary. The hidden sky begins to fill with structure. One might picture the process like cleaning an old window. At first, only smears and shadows, then a shape, then many shapes, then a landscape beyond. The Milky Way's dust has not disappeared, but our instruments have found paths through it. This is another aspect of the mystery. The Great Attractor is not hidden equally at all wavelengths. It is the visible universe that is especially blocked. Other messengers can pass more freely. The sky has layers of transparency. Visible light sees stars and dust. Infrared sees deeper through dust. Radio waves reveal gas. X-rays reveal hot clusters. No single wavelength owns the truth. The universe must be listened to in many registers. A mysterious object in one wavelength may be clearer in another. A dark region of the optical sky may glow in radio or X-rays. The Great Attractor is therefore also a story about how observation depends on the kind of light we use. Human eyes evolved under the sun. We see the wavelengths useful on Earth. But the universe speaks across the electromagnetic spectrum. To understand it, we must become more than eyes. We build radio dishes, infrared telescopes, X-ray observatories, microwave satellites. We extend perception. The Great Attractor required this extended perception. And still, some details remain hidden. The region behind the thickest Milky Way dust remains difficult. NASA notes that even with tricks like infrared and radio observations, the region behind the center of the Milky Way, where dust is thickest, remains an almost complete mystery to astronomers. An almost complete mystery, even now. In an age of space, telescopes, galaxy surveys, and cosmic microwave background maps, there are still directions where the universe is veiled. This is good to remember. Science does not remove mystery from the universe. It reveals where the true mysteries are. The Great Attractor has survived as a mystery not because science has failed, but because science has made the mystery precise. We know enough to know where the uncertainty lies. We know the region. We know the motions. We know some of the clusters. We know the obstruction. We know Shapley matters. We know Laniakea reframes the flow, and we know the map is still incomplete. That is a mature mystery, not a vague unknown, a structured unknown. The Great Attractor sits in the space between what is mapped and what is inferred. There is a kind of calm in this. The universe is not chaotic because we do not know everything. The unknown has shape. The hidden has gravitational influence. The missing galaxies are not outside law. They are simply outside easy vision. As the script continues, let the Great Attractor become less like a threat and more like a presence. A shadowed valley, a hidden shore, a distant convergence, a region of gravity behind the bright dust of home. Imagine now the galaxies near the Great Attractor. They do not know they are part of a named mystery. The names are ours. Norma, Hydra, Centaurus, Shapley, Laniakea, Zone of Avoidance. The galaxies simply move. Spiral arms turn, stars age, gas falls into clusters, black holes feed quietly in galactic centers. Dark matter halos overlap. Gravity works. Human names are small lamps placed on a vast landscape. But without names, we cannot speak. The Great Attractor is one of those lamps. It illuminates a question. Why does our cosmic neighborhood move the way it does? The answer involves the mass around us, but not just the mass we see. It involves distance, structure, dark matter, hidden clusters, and the long history of gravitational growth. It also involves errors, corrections, and better surveys. This is the story of science as a slow approach. The first impression, something huge is pulling us. The next impression, the pull comes from a region hidden behind the Milky Way. Then, the Norma Cluster is central. Then, the Great Attractor alone may not be massive enough. Then, Shapley contributes strongly. Then, Laniakea defines a basin of flow. Then, even larger and newly mapped structures may further refine the picture. At every stage, the mystery changes but does not disappear. It becomes less mythical and more cosmic. This is what good science does to wonder. It does not erase it. It deepens it. The Great Attractor's attraction is not mysterious because gravity itself is unknown. We understand gravity well enough to predict planetary motion, gravitational lensing, galaxy clusters, and large-scale structure. The mystery is the distribution of mass, where it is, how much there is, how it is arranged, how hidden regions contribute, and how far the relevant flows extend. The universe is not pulling us from nowhere. Mass is pulling. But finding all the mass is hard. And because the universe is mostly dark matter and dark energy by cosmic composition, and because ordinary matter itself can be hidden or diffuse, mass is not always where light makes it obvious. This gives the Great Attractor a philosophical edge. We move according to the whole, not merely according to what we can see. The visible is not the entire cause. The hidden matters. Dust-hidden galaxies matter. Dark matter matters. Distant superclusters matter. Underdense voids matter. The motion of home is produced by a reality larger than appearance. This principle reaches far beyond astronomy. In the cosmos, as in many things, what is visible is only part of what is real. But the Great Attractor makes that truth physical. The invisible pulls. The unseen shapes motion. The background matters. Consider a galaxy near a cluster. If we could watch over billions of years, it might fall inward, accelerated by the cluster's gravity. As it enters the cluster, hot gas may strip its own gas away. Its star formation may change. Its shape may be altered by tides. It becomes part of the cluster environment. Now, scale that up. Groups move toward clusters. Clusters move toward superclusters. Filaments feed knots. Voids empty. The universe is not static architecture, it is living structure. Not living biologically, but evolving dynamically. The Great Attractor is one of the places where this evolution can be read. It shows that galaxies are not just expanding away in perfect solitude. They are also gathering, streaming, responding to the density field. The universe expands globally. Gravity gathers locally. The Great Attractor is where the gathering remains strong enough to leave a mark on motion. This balance between expansion and attraction is central to modern cosmology. On small scales, gravity can overcome expansion and bind structures. The solar system does not expand. The Milky Way does not expand. The local group is bound. Galaxy clusters can be bound. But on larger scales, expansion dominates, and structures not gravitationally bound may drift apart. Superclusters occupy the uncertain middle. They are impressive, meaningful structures, but not necessarily bound forever. The Great Attractor region is gravitationally significant now, but it is embedded in a universe whose large-scale expansion continues. This means the word attracts must be held gently. It does not mean everything nearby will end there. It means the mass distribution creates peculiar velocities, measurable deviations from uniform expansion, streams toward denser regions. The Great Attractor pulls in the language of velocities, not apocalypse, not destiny, flow. There is mystery enough in flow. The direction of the local group's motion relative to the CMB is one of the great clues. The cosmic microwave background gives a reference frame, a kind of average rest frame of the early universe. A motion through that radiation produces the dipole pattern. That motion is not caused by the CMB itself, it is revealed by it. The cause lies in gravitational interactions with structures in the universe. The CMB is the background. The galaxies are the moving foreground. The Great Attractor is part of the gravitational explanation. This ties the ancient universe to the present one. The CMB comes from when the universe was young, nearly uniform, and hot. The Great Attractor is a structure formed much later by gravity amplifying small density variations. The motion of the local group relative to the CMB connects these eras: early smoothness, later clumpiness, present motion. In a single measurement, the dipole carries cosmic history. The early universe provides the frame. The later universe provides the pull. Our motion is the result. This is beautiful. The Great Attractor is not only a nearby structure, it is a consequence of the universe's evolution from smooth beginning to cosmic web. Every galaxy cluster is, every filament is, every void is. The Great Attractor is an especially dramatic local example because it lies in the direction of our motion and behind the veil of the Milky Way. The hidden valley is part of the universe becoming structured. Imagine the early universe, almost smooth, with tiny differences in density. Over billions of years, the dense regions pull in matter. Small clumps grow, dark matter forms halos, gas falls in, stars ignite, galaxies assemble, clusters form, filaments connect, voids widen. Eventually, somewhere in what we now call the Norma region, enough matter gathers to create a gravitational basin, not isolated, connected to other basins, connected to Shapley, connected to the cosmic web. The Great Attractor is born not in an explosion, but in accumulation. Gravity does not hurry. It works across time. It whispers matter into structure. The result, billions of years later, is a hidden region toward which galaxies stream. There is no single moment when the Great Attractor formed. It emerged, like a valley carved slowly by water. Like a city growing from roads and settlements. Like a storm system forming from pressure differences. The Great Attractor is an emergent feature of cosmic structure. This is another reason. It resists simple description. A star has a birth. a supernova has a moment. A black hole may form and collapse, but a supercluster basin emerges over cosmic time through the combined motion of countless masses. Its beginning is gradual, its edges are blurred, its influence is collective. This collective nature is the true awe, not one thing pulling us. Many things together: galaxies, clusters, dark matter, filaments, hidden mass, distant concentrations, voids. The Great Attractor is not a single hand, it is the weight of a landscape. The Milky Way moves through that landscape as naturally as a river follows gravity down a valley. But unlike a river, the Milky Way contains stars, planets, and minds. Every night on Earth, people look upward from within a galaxy flowing through a cosmic valley. Most never know it. The movement is too vast and too silent. But it is there. Now let us turn toward the Great Attractor as though traveling outward, leave Earth. The atmosphere thins into blackness. The moon becomes a gray companion. The planets become points. The sun becomes one star among many. The spiral of the Milky Way stretches around us, luminous and immense. We leave the disk, rising above it, and for the first time the zone of avoidance becomes understandable. From inside the disk, it is a band of obscuration. From outside, it is simply the Milky Way itself, full of dust and stars, blocking the background for observers within. Beyond the disk lies the local group: Andromeda, Triangulum, dwarf companions, streams, dark matter halos. The local group is falling toward its future merger, but it is also moving as part of a larger cosmic flow. Farther out, the Virgo cluster appears, a rich gathering of galaxies. Beyond, the filaments and clusters of the local universe, the Hydra-Centaurus region, the Norma Cluster, the Great Attractor Valley. Farther still, the Shapley supercluster. From far enough away, the pattern becomes visible. Our motion is not toward an isolated dot. It is toward a connected overdense region, with Shapley beyond it, all part of the larger structure of matter around us. The journey outward changes the mystery. From Earth, the Great Attractor is a hidden pull. From the cosmic web, it is a knot in the pattern. Both views are true. Mystery is often a matter of perspective. Close up, the veil dominates. Far away, the web appears. But we cannot take that far view physically. We must build it through observations. This is why cosmic maps are among humanity's strangest creations. They are not photographs in the ordinary sense. They are reconstructions of a three-dimensional universe from light that arrives on a two-dimensional sky, with distances inferred, motions corrected, obscured regions filled, and uncertainties managed. A map of the Great Attractor is an act of interpretation, but not arbitrary interpretation. It is interpretation constrained by data. The universe gives clues. Science arranges them. The Great Attractor is one of the places where this arrangement remains difficult and therefore fascinating. As the map improves, the story may continue to change. More galaxies may be found behind the zone of avoidance. Mass estimates may be refined. The contribution of Shapley, Vela, and other structures may be better understood. Cosmic flow catalogues may grow. New telescopes may see deeper through dust. The Great Attractor of future astronomy may not be exactly the Great Attractor of the 1980s or of today. But the core idea will remain. Our galaxy's motion is shaped by the large-scale distribution of matter, including mass, partly hidden behind the Milky Way. This is the fact at the heart of the mystery. Hidden mass, measured motion, cosmic flow. Let the narration linger there. Hidden mass, measured motion, cosmic flow, a simple three-part rhythm for something almost incomprehensibly vast. There is also a reason the Great Attractor's story belongs especially to the southern sky. Norma, Centaurus, Triangulum, Estrella, Hydra, Pavo, Indus, Vela. Many of the relevant structures lie in directions best observed from southern latitudes. The history of mapping them involves southern observatories, photographic plates, radio surveys, X-ray surveys, and international collaborations. The sky itself is divided by place. What is high in one hemisphere is low in another. The Great Attractor is not equally accessible from everywhere on Earth. This is a reminder that astronomy, though cosmic, is also geographical. Where telescopes are built matters. What skies they see matters. The southern sky holds parts of the story that northern observers long struggled to study fully. The universe is universal, but observation is local. In that sense, the Great Attractor belongs not only to cosmology, but to the human geography of science. Observatories in Chile, South Africa, Australia, Hawaii, space telescopes above Earth, radio dishes listening through dust, X-ray satellites marking clusters. The hidden region required a planet-wide effort. No single eye could solve it. The cosmos is too large for one instrument. It demands many. This is fitting, because the Great Attractor itself is collective. A collective mystery studied by collective science. Now let us look closer at the Norma Cluster. A galaxy cluster is one of the largest gravitationally bound structures in the universe. It can contain hundreds or thousands of galaxies, vast amounts of hot gas and dark matter. The galaxies are only a small fraction of the total mass. The hot gas between them can be more massive than the galaxy's stars. Dark matter dominates the cluster's gravity. In visible light, a cluster is a swarm of galaxies. In X-rays, it is a glowing cloud of hot plasma. In gravitational lensing, it is a mass-bending light. In dynamics, it is a system of galaxies moving within a shared gravitational potential. The Norma Cluster, hidden near the Milky Way's plane, is important because it represents a massive concentration in the Great Attractor region. It is one of the clearest known structures behind the veil. Its existence gives substance to what was once a more abstract flow. But clusters alone do not tell the whole story. The Great Attractor region extends beyond one cluster. Galaxy walls and filaments contribute. The mass distribution is spread across space. Nearby clusters and groups participate. Dark matter extends beyond visible galaxies. This distributed structure is why the Great Attractor is better thought of as a region than a point. If one could draw gravity as contour lines, the Great Attractor would be a broad lowland, not a needle. Galaxies do not all fall into one central object. They respond to the whole terrain. This distinction matters for accuracy and for atmosphere. A point attractor is dramatic but false. A gravitational lowland is quieter but more cosmic. It suggests scale. It suggests a landscape too large for sharp edges. It suggests that the universe itself has topography. The Great Attractor is a topographical feature of space-time and matter. Not a mountain, but a valley. Not visible as a valley to the eye, but traced by motion. This image can guide the whole documentary. A valley behind the stars. The Milky Way as a luminous fog. Galaxies as rivers. The local group as a drifting vessel. The Great Attractor as the low dark place toward which the water leans. But beyond that valley, a deeper descent toward Shapley. And perhaps beyond Shapley, still larger currents. It is valleys all the way outward. Not infinite, but layered. This layered motion brings us to another thought. The Great Attractor is not a violation of cosmic expansion. It exists inside expansion. This is a subtle but important point. People often ask, if the universe is expanding, how can galaxies be attracted toward one another? The answer is that expansion dominates on large enough scales, but gravity can create local and regional motions. Bound systems do not expand. Galaxies, groups, and clusters are held together by gravity. Even outside bound systems, mass concentrations can create peculiar velocities that deviate from smooth expansion. The Great Attractor is one such deviation. Galaxies in its region may still be receding from us overall because of cosmic expansion, but their velocities contain an extra component directed by gravity. They can be moving away and being attracted at the same time because the expansion and peculiar motion are layered. This is like walking upstream on a moving walkway. Your motion relative to the walkway and the walkway's motion relative to the ground combine. In the universe, the Hubble flow is the broad motion. Peculiar velocity is the local walking. The Great Attractor affects the walking, not the existence of the walkway. Of course, the analogy is imperfect. Space is not a literal conveyor belt, but it helps separate the motions. The Great Attractor is not pulling galaxies out of an otherwise static universe. It is shaping their deviations within an expanding one. The result is a cosmic flow pattern, and that pattern can be mapped. When astronomers map peculiar velocities, they are mapping gravity indirectly. They are measuring how matter has responded to the density field. This is powerful because some mass cannot be seen directly. Velocities reveal the gravitational sum. In a sense, the Great Attractor is not only an object of study, it is a method, a way of understanding how cosmic structure reveals itself through motion. It teaches us that mapping the universe requires more than counting galaxies. A region with many visible galaxies may not tell the full mass story. A hidden region may still influence motion. A distant mass concentration may contribute more than a nearby one if it is large enough. Voids may influence flows by absence. The universe must be mapped dynamically, not just where things are, but where they are going. The Great Attractor is one of the first great lessons in dynamic cosmography. Cosmography means mapping the universe. Dynamic cosmography means mapping it through motion. This is where the story of Laniakea becomes central. The 2014 work defining Laniakea used galaxy velocities to trace boundaries of a supercluster basin. The National Radio Astronomy Observatory reported that mapping velocities throughout the local universe allowed the team to define the region where each supercluster dominates, placing the Milky Way on the outskirts of Laniakea and clarifying the role of the Great Attractor as a gravitational focal point. This is a beautiful idea. Our cosmic home is defined not only by location, but by motion. Not only by where we are, but by where the flow carries us. A home supercluster as a basin, a home as a current. This is different from older cosmic addresses. Earth, Solar System, Milky Way, Local Group, Virgo Supercluster, Laniakea. Each name expands the address, but Laniakea adds motion to the address. It says, "We belong to the stream that descends toward this valley." The Great Attractor gives that address direction. Without it, Laniakea would be only a region. With it, Laniakea becomes a flow. This does not mean every galaxy in Laniakea is literally falling into the Great Attractor forever. The flows are present-day peculiar velocities in a complex expanding universe. But as a map of current gravitational influence, the image is powerful. The galaxies flow inward like water. The Great Attractor is the valley. The Milky Way is one droplet on the slope. It is difficult to think of the Milky Way as a droplet. It contains everything we have ever known directly. The entire human story, all of life on Earth, every civilization, every ocean, every fossil, every forest, every forest, all within one tiny planet, orbiting one star in one galaxy. Yet in the Laniakea map, the Milky Way is a dot among many, moving along a line. This change of scale is one of astronomy's deepest gifts. It does not make life smaller in value, it makes the stage larger. The Great Attractor is part of that enlargement. It reveals that even our galaxy has a context beyond itself, and context beyond that, and beyond that. There is no final, comfortable scale at which the universe becomes simple. Every scale opens. The Great Attractor also touches the question of what we mean by known. Is something known if we cannot see all of it? Astronomers know the Great Attractor through converging evidence. They know the Norma Cluster exists. They know the region is obscured. They know galaxy flows converge. They know Laniakia's motions. They know Shapley contributes. But the exact distribution of mass, especially behind the thickest Milky Way dust, remains uncertain. So the Great Attractor is both known and unknown. This is common in science. Knowledge is not a switch. It is a landscape of confidence. Some areas are bright, some are dim, some are inferred, some are contested. The Great Attractor is mapped well enough to be real, but not completely enough to be finished. That makes it ideal for a mysterious narration. The mystery is true. It is not invented. The Great Attractor is not a blank fantasy. It is a partially illuminated structure, with shattered areas remaining. The Milky Way moves toward it. The Norma Cluster lies within it. Laniakea converges there. Shapley lies beyond. And the veil remains. This is the kind of mystery that can last, because every answer contains another distance. Let us follow the flow backward. If the local group is moving, what set that motion in place? Gravity acts over time. The current velocity of the local group is not caused only by the present positions of masses, but by their integrated gravitational influence over cosmic history. As structures grew, they pulled matter toward them. The local group's motion developed as nearby and distant overdensities shaped its path. The Great Attractor is part of that history. So the motion we measure now is ancient. It is the result of billions of years of gravitational acceleration. The Milky Way has not suddenly begun moving toward the Great Attractor. It has been shaped by the evolving density field since the early universe. The flow is a memory of structure formation. In this sense, the Great Attractor is not simply ahead of us. It is behind us in time. It helped shape the motion we already have. Gravity does not only define where things will go, it records where they have been. Every velocity is history. The Milky Way's motion is a fossil of the universe's mass distribution. This is a profound idea. The speed of our galaxy is a record of invisible forces acting across cosmic time. The Great Attractor is one entry in that record, Shapley is another, voids are another. The cosmic web writes itself into the velocity of galaxies. To read that writing, astronomers need distances, redshifts, maps, and models. This turns the universe into a kind of ancient manuscript. The ink is light. The grammar is gravity. The Great Attractor is a half-hidden sentence. Now, as the narration deepens, imagine the Great Attractor not as a luminous object, but as a dark pressure in the map. Galaxies above the Milky Way's plane lean one way. Galaxies below it lean similarly. Clusters show motions that do not match smooth expansion. Behind the obscuring band, X-ray sources reveal massive clusters. Farther beyond, Shapley waits like a deeper basin. The whole region becomes a gravitational corridor. From our vantage, it lies behind the Milky Way's brightest confusion. No wonder it captured imagination. A hidden corridor of galaxies, a direction of motion, a name like a warning. The Great Attractor. But the warning is not danger, it is scale. It warns us that the universe is larger than our immediate maps. It warns us that visibility is not completeness. It warns us that our galaxy is not still. It warns us that every cosmic address may be provisional. It warns us that the deeper universe is structured by things we may not yet fully see. There is comfort in this too, because a universe with hidden structure is not empty. The dark is not void, it is full of relationships. Gravity connects what light may hide. The Milky Way and the Great Attractor are separated by hundreds of millions of light years, but they are not unrelated. Their relationship is written in the flow of galaxies, in the long-range influence of mass, in the shared evolution of the cosmic web. The universe is relational. Nothing exists in complete isolation. Even an isolated-looking galaxy belongs to a larger density field. Even a void is defined by what surrounds it. Even the Milky Way's motion belongs to structures beyond sight. The Great Attractor is a reminder that the cosmos is not a collection of lonely objects, but a network, a web of gravity, history, and motion. Perhaps this is why it feels so mysterious. It is not a thing we can separate from the rest. It is a knot in the web, and to understand the knot, we must understand the web. The Great Attractor also has a paradoxical quality. It sounds like a center, but it reveals that centers are relative. For galaxies in Laniakea, the Great Attractor region is a convergence in the local flow. But in a larger view, Shapley may dominate. In an even larger view, other structures and voids matter. There may be no final center of motion, only nested flows. The universe itself, on the largest scales, has no central point in the ordinary sense. The Big Bang was not an explosion from a center into space, it was the expansion of space everywhere. The cosmic web has dense nodes, but no universal center. The Great Attractor is a local center of flow, not the center of the universe. This distinction is important. The Great Attractor is central to our region, not central to all reality. It is a local gravitational feature in an immense cosmos. Its mystery comes partly from our location. To another civilization, in another supercluster, another attractor, another basin, another hidden mass concentration might dominate their cosmic motion. Our Great Attractor is great because it is ours, part of our flow, part of our sky, part of our map, not because it rules the universe. This is a humbling correction. Even our mysteries are local. But local, in cosmology, can still mean 500 million light-years. The Great Attractor is our neighborhood mystery, a neighborhood vast enough to contain more galaxies than human imagination can easily hold. If we listen to the name Laniakea, immense heaven, we can feel the right scale. A supercluster, 500 million light-years wide. 100,000 galaxies, a gravitational valley, a hidden region, a flow toward Norma, a greater flow toward Shapley. The sky becomes not a dome, but a terrain. The Milky Way becomes not only a home, but a veil. The local group becomes not only a family, but a traveler. The Great Attractor becomes not only a mystery, but a direction. And the universe becomes not only expanding, but flowing. This word, flowing, is central. Galaxies flow. Not like water in any simple physical sense, but in the sense that their peculiar velocities trace gravity's landscape. Flow captures motion without implying panic. It suggests silence. It suggests continuity. It suggests time. The Great Attractor is a flow mystery. A mystery of where the cosmic river bends. If this documentary were a journey, we would not travel in a straight line to a point. We would drift with the flow, noticing how more and more of the landscape appears. At first, only our motion, then the hidden direction, then the Zone of Avoidance, then Norma, then Laniakea, then Shapley, then voids, then the cosmic web. The Great Attractor is the beginning of a widening. It begins as a single question: why are we moving? It ends by revealing the architecture of the nearby universe. This makes it one of the most elegant topics in cosmology. It connects local motion to large-scale structure. It connects the Milky Way to hidden galaxies. It connects the CMB to galaxy flows. It connects observation limits to cosmic geography. It connects mythic naming to careful science. And it connects mystery to humility. The Great Attractor is not merely something out there. It is part of the answer to where we are, not just in space, in motion. Most maps show position. The Great Attractor belongs to a map of movement, and a map of movement is closer to reality because the universe is never still. Now imagine a future observatory, perhaps a radio array far more sensitive than today's, perhaps infrared surveys deeper and clearer than any before, perhaps new X-ray maps of hidden clusters, perhaps gravitational lensing maps that trace dark matter behind the Milky Way. With these tools, future astronomers may fill in the zone of avoidance with greater precision. The hidden galaxies may emerge. The mass distribution may sharpen. The Great Attractor region may be renamed, subdivided, reinterpreted. And yet, the old name may remain in memory. The Great Attractor. A name from the era when the pull was felt before the source was clearly seen. There is something valuable in preserving that history. Science is not only facts, it is the path to facts. The Great Attractor's name preserves the sensation of being drawn toward the unknown. Even when the unknown becomes mapped, the sensation remains. Because beyond the mapped region lies another unknown. There is always a farther structure, a deeper survey, a fainter flow, a more complete model. The universe recedes from finality. Every map has an edge. The Great Attractor once lived at such an edge. It still does, in a way, because the zone of avoidance has not fully surrendered. The edge is now better known, but not gone. The night retains its veils. Let the mind return to Earth, a quiet landscape under stars, the Milky Way above, pale and dusty. Somewhere behind that band, hidden by the galaxy's own light, lies the direction of the Great Attractor. You cannot point to it easily from ordinary vision. You cannot see a glowing object. You cannot watch the Milky Way move. But the motion is real. The galaxy carries you. The local group carries the galaxy. The flow carries the group. The Great Attractor helps shape the flow. The distance is vast, the effect gentle, the timescale immense. There is no urgency, only participation. This is the right emotional tone, not fear, but awe, a dark awe. The awe of being drawn by hidden structure, the awe of knowing that home is moving through a cosmic landscape, the awe of realizing that the sky contains not just objects, but directions of gravity. The Great Attractor is mysterious because it reveals motion where we expected stillness, hidden mass where maps were blank, and structure behind the bright confusion of our own galaxy. It is mysterious because it is not fully visible. It is mysterious because it is not one thing. It is mysterious because it is not the final answer. It is mysterious because it leads onward, from Norma to Laniakea, from Laniakea to Shapley, from Shapley to the cosmic web, from the cosmic web to the early universe. From the early universe to the question of why matter formed this pattern at all, every answer points deeper. The Great Attractor is a doorway disguised as a destination. Perhaps the most haunting part is that we discovered it by noticing that the universe was not moving the way a simple model said it should. A deviation, a small mismatch, a peculiar velocity. Science often begins there. Something is slightly wrong. A planet does not orbit quite as expected. A star's spectrum shifts. A galaxy rotates too fast. A background radiation has a dipole. A cluster appears behind dust. A flow points into the obscured sky. The Great Attractor began as such a mismatch, a whisper in the velocities of galaxies. And from that whisper came a vast hidden landscape. This gives the story a quiet suspense, not the suspense of danger, the suspense of discovery. What lies behind the Milky Way? What mass is hidden? Why do galaxies stream this way? How far does the flow extend? What part is Norma? What part is Shapley? What part is the absence of matter in nearby voids? What remains unseen? The questions move slowly, like galaxies themselves. They do not need quick answers. They ask to be carried. As a final deepening, Consider that the Great Attractor may not even be the best name for the main cause of our motion anymore. The science has evolved. The Shapley supercluster and other large-scale structures play major roles. The Great Attractor is part of the local flow, not the sole master of it. But the name still marks a real region and a real historical puzzle. This is how science sometimes preserves older language inside newer understanding. We still speak of sunrise, though Earth rotates. We still speak of shooting stars, though meteors are not stars. We still speak of planetary nebulae, though they are not planets. And we still speak of the Great Attractor, though it is not a single attracting object. The name remains because it points to a real experience of discovery. Something was pulling. Something was hidden. Something great lay in that direction. Even if the something became a network rather than a point, the name survived, and perhaps it should. Because the Great Attractor is not only a scientific label, it is an invitation. An invitation to imagine the Milky Way in motion. An invitation to look through the Zone of Avoidance. An invitation to think in flows rather than fixed positions. An invitation to see darkness as structured. An invitation to accept that the universe we inhabit is larger and stranger than the universe we can directly see. Now, let the scene widen one last time. The Earth turns. The Sun moves through the Milky Way. The Milky Way drifts with the local group. The local group streams through the cosmic microwave background. Ahead, in a direction partly hidden by our own galaxy, lies the Norma region, the Great Attractor Valley. Beyond it, the Shapley supercluster, richer and farther, shaping a larger motion. Around us, Laniakea spreads like an immense heaven, a basin of galaxies, a gravitational watershed hundreds of millions of light-years across. Beyond Laniakea, other basins, other filaments, other voids, other flows. The cosmic web fades into the observable universe, and the observable universe fades into horizons beyond which light has not had time to reach us. Everywhere, matter moves. Everywhere, gravity remembers. Everywhere, expansion carries the largest scales outward. The Great Attractor is one thread in this vast pattern, a dark thread, a hidden thread, a thread connected to our motion through space. It does not shine like a star. It does not blaze like a quasar. It does not erupt like a supernova. Its power is quieter. It bends the paths of galaxies. It gives direction to a region of the universe. It hides behind the Milky Way and reveals itself through the motion of things that are not hidden. That is its mystery. A presence known by its consequences, a valley known by its streams, a darkness known by the way light moves around it and galaxies move toward it. And as the night continues, as the Earth turns beneath the stars, that motion goes on, without sound, without haste, without needing to be seen. The Milky Way flows through the cosmic dark. The Great Attractor waits, not as a monster, but as a hidden geography, a vast gravitational lowland behind the stars of home. A reminder that the universe is not merely expanding, it is moving in patterns. It is flowing, it is gathering, it is concealing and revealing itself at the same time, and we are carried within it.